Good morning to all of you. Today I am recording the lesson for day 31. Today I am starting the new chapter, shear force and bending moment diagrams. In the previous classes we have been discussing about the force systems, simple stresses and strains, geometrical properties of sections. And now this is the fourth chapter, that is shear force and bending moment diagrams. Now I am sharing the PPT. Here in this class where we will discuss about the types of beams and we will define the shear force, bending moment, and we will try to learn how to draw the shear force and bending moment diagrams. So our objectives to know the types of beams, types of loads, and defining the SF and VM and SFD and VMD and sign conventions, and we also know the procedure to construct the SFD and VMD. Now, first of all, when we want to enter into the SFD and VMD, we should know some of the basic things. In that, the first one is the beam. What is a beam? So we are seeing the beam at so many places. It finds public applications in the various fields, various places in the engineering applications. So in the while constructing a building, a beam is constructed to support the load, to take up the load. So beam can be defined as a member which is subjected to vertical loads. So generally, so the beam is in the horizontal condition like this. So it is a member generally standing in the horizontal direction. It is supported by the two or more supports, or in case some single support, and here it is generally laid horizontally, and here it is subjected to some vertical loading like this. The load will act at an angle perpendicular to the axis of the beam. So this is the axis of the beam. The axis is horizontal, parallel to ground. Now the load will be acting at 90 degrees to the axis, at perpendicular to the axis of the beam. So that member is called as a beam. So any member subjected to vertical loads is called as a beam, and it is subject to the beam is subject to bending due to external loads, and the beams are generally horizontal and they are very straight. The beams are straight and horizontal, and so we should know the load carrying capacity of the beam. So that plays very important role in designing of the beams and to find their suitability in the different places. So a beam can be defined as a horizontal member which is subjected to vertical loads. Now the bending, generally when a beam is subjected to the external load, it is subject to bending. So the amount of bending of the beam depends on the following factors. The first one is the amount and type of the load. So if the load is more, it produces more bending deflection. The deflection of the beam is more, it produces more bending action. And if the type means if it is a steadily applied load, the bending action will be somewhat less. If it is suddenly applied load, it produces more bending action, like that. Next, the bending also depending on the length of the beam. If the length is more, that is, then it produces more bending moment. As the length is more means the bending moment is nothing but the force into distance. So the distance increases when the length is more, it produces more bending moment. And if the length is short, it produces less bending moment. And elasticity of the beam. If the modulus of elasticity is more, then we can say the beam is rigid and subjected to less amount of deflection. If the value of E is less, then it produces more deflection in the beam. And also type of beam. The beams are also of different types: cantilevers, simply supported beam, overhanging beam, continuous beam depending on the supports location. Then accordingly also the amount of bending of the beam will depend on the type of the beam, that we will discuss in detail. Now the type of beams. So a beam is a member which is subjected to horizontal, which is subject to vertical loading. It is a horizontal member subjected to vertical loading. And here, depending on the location of the supports, the beams are classified into the following types. They are: first one, the cantilever beams; second one, simply supported beams; third one, overhanging beam; fourth one, rigidly fixed beam, that is also a fixed beam. Next, fifth one is a continuous beam. So that we will discuss one by one in detail. So this is the beam. So actually this green color part, so this member, so it is having some cross section area and length, and it is also having some cross section. So depending on the different applications, we will have the different cross sections. So generally a rectangle cross section will be employed in general. And here it is having a length and also some cross sectional area. And here, so this beam is mounted horizontally, and here it is subjected to the loads vertically. That means the loads are acting at right angles to the axis of the beam. So then this member is called a beam. And here, now coming to the cantilever beam. So in case of the cantilever beam, if the one end of the beam is fixed, so here we got this is one end and this is the other end. So here, if one end of the beam is fixed and other is free, then this type of beam is called the cantilever beam. So only one end of the beam is fixed, and it will never have another support, only one support, that is only one end of the beam is fixed. and other end is left free, and then the load is applied, and this kind of beam is called as a cantilever beam. And here, so this the beam at which the end of the beam at which it is fixed is called as a fixed end, and the other end of the beam is called as a free end. Here there is no support. And the examples, if we take portico, so in case of the portico building is like this. So for example, this is a slab. This is the slab of the portico. So this slab is only supported at one end. The other end is left free. So that is also example for the cantilever beam. And also railway signal post. So generally in the mechanical signaling system, so they are like this. Whenever the train is stopped, when we have to stop the train, it will be at this condition, and when we wanted to allow the train in the track, then it will be lifted like this. So here what is happening is only one end is fixed, other end is left free. This is called as the cantilever beam. And next, the simply supported beam. Here, if the two ends of the beam are simply supported or freely supported, then this beam is called as the simply supported beam. It is also known as SS beam. So here what is happening is at the two ends the member is supported freely. And so the examples are the culverts and single span bridges. So at the bridge also, so what is happening is, so it is having the span like this, and at both ends it is supported like this. So this is a bridge, a single span bridge, and at both ends it is supported like this. So this is the example for the simply supported beam. So a beam which is supported freely at both ends is called as the simply supported beam. Next one is the overhanging beam. So this is also one kind of the simply supported beam. That means it is also in the two supports, minimum two supports. But instead of having the support at the end, the support may be placed not exactly at the end of the beam, but the support is placed at some distance from the end. So this portion is called as the overhanging portion, the distance between the end of the beam and the support. So this is called the overhang portion. And the good example of the overhanging beam is automobile vehicle, because the automobile is supported on the wheels, but the body of the automobile is extended beyond the wheels at both sides. So it will be having the overhang at both sides. So that is called as the overhanging beam. Next, the rigidly fixed beam. Here, if the both ends of the beam are rigidly fixed at both sides, then that beam is called as the rigidly fixed beam, or simply it is called as the fixed beam. Rigidly fixed is nothing but a fixed beam. A fixed beam is, in case of the fixed beam, the both ends of the beam are rigidly fixed. So here what is happening? There is no question of moving of the ends. The movements of the ends are stopped by the fixed supports. So the good example of this fixed beam is roof, that is slab, Here what is happening at both ends? So for example, we got two beams and the slab is laid between the two beams. So that means the roof or the slab is fixed between the two beams. Then that is a good example for the fixed beam. And a continuous beam. So very simple. It is also an extension of the simply supported beam. How? If we take the case of the simply supported beam, so it has got only two supports. So the beam is supported only at the two ends. Then it is called as the simply supported beam. But in case of the continuous beams, if if you see what is happening in the present case, it is having the three supports. Sometimes maybe four supports and so on. That means if the beam is having the supports at more than 2 points, maybe three or more, then that beam is called as the continuous beam. So a continuous beam is supported at more than the 2 points over the length. And sometimes it may have the overhanging or it may not be having the overhanging. So that overhanging may be at both sides or maybe at a single side, whatever may be the case. But if the beam is having the supports at more than 2 points, then that beam is called as a continuous beam. So the example is multi-span bridges. So a single span bridge is a example for the simply supported beam, and multi-span bridge is an example for the continuous beam. So they are the beams. Now coming to the loads, because a different kind of loads are acting on the beam. So first of all, we should know what are the loads and how they will produce the effect on the beams. So what is called load? How do you define the load? The load may be defined as the external force acting on the member. The load may be defined as the external force acting on the member is called as the load. So generally the load will be acting at perpendicular to the axis of the member, then it is called beam. So generally in the beams the load is acting at right angles to the axis of the beam, and the loads are of the following types. The first one is the concentrated load or point load. Second one is the distributed load. So in the distributed load we got again two types. One is the uniformly distributed load, UDL. Next the uniformly varying load, that is the triangle load. So this we will discuss one by one in detail. First one is the concentrated load, or it is also called as the point load. So what is this one? As the name is indicating, point load. That means when a load is acting at a point on the beam, that means its effect is limited to a point on the beam. The point means the area of the point is very small as compared to the area of the beam. So it is acting at only at a smaller point, having a smaller area. So that area is negligible. The load, in case of the point loads, the area at which the load is acting is negligible when compared to the area of the beam. That means it's just a point on the beam. That means the load is acting at a point, and so that's why it is called a point load, or it is also called as the concentrated load. That means the load is concentrated only at a point. So this is the, I think it is clear, the point load or concentrated load means if the load is acting at a point on the beam, or it is concentrated only at a point on the beam, then it is called as the concentrated load or the point load. Next one is the distributed load. In the second case, here what is happening is, in this case the load will not be confined to a point, but it is distributed over the area, any area. Sometimes the whole area of the beam, sometimes whole length of the beam, sometimes only the part length of the beam. It may be acting. That means the load is distributed throughout the, sometimes the along the length or along the area, sometimes the whole length, sometimes the whole area, or sometimes only the part length or the part area. Then that load is called as the distributed load. If the load is acting such that its magnitude is distributed equally throughout the length of the beam, then it is called as the distributed load. And if the magnitude is equal at all points, at any point, then at any point along the length through which the force is acting, then it is called as the uniformly distributed load. And on the other hand, if the magnitude of the load is varying throughout the length, that means if it is starting at 0 point and gradually increasing to the maximum value throughout the length of the beam, then it is called as the uniformly varying load. So generally we will come across with the uniformly distributed load, that is also the UDL. So here, first of all, we should be able to know what is the distributed load. Distributed means if the magnitude of the load is distributed throughout the length or throughout the area, then it is called as the distributed load. In this case also two types. One is the uniformly distributed load, UDL, and the second one is the non-uniformly distributed load, that is also the uniformly varying load, that is VDL. Uniformly varying load, that is VDL. And in this case, in case of the uniformly distributed load, the magnitude of the load is equal at any point toward the length in which the force is distributed. And if the magnitude of the force is not equal, and the magnitude of the force is gradually either increasing or decreasing from one point to the other point throughout the length, then it is called as the uniformly varying load. And if we take the uniformly varying load, sometimes the load is gradually increases from zero value to the maximum value, and in this case the magnitude of the load will be taken as the average value of the load. And that uniformly varying load means that is the case of the triangular load. That is, first of all, UDL, that is uniformly distributed load, means it is a rectangular load. That is, rectangular means always the width will be same. And uniformly varying load means the at one point it is zero, at the other point it is just to the maximum. That is a triangular load or a trapezoidal load, like that. And now these are the figures pertaining to the different beams. Now this is the when the loads are applied. So this is the beam. So here all are what kind of beams? Here if you see the beam is supported at the two ends in all the cases, in the three cases. So this beam is a simply supported beam. And now coming to the loads. So this is the only the load W. So it is acting at a point on the beam. So this is a point load. And here, so this is the, here what is happening is the load is acting throughout the length. So if we take throughout the length, the magnitude or the intensity of the loading is same. So this is called as the uniformly distributed load, that is the UDL. And generally the UDL, the point load is shown like this because the force is acting at a point. Simply we can show it as a load acting at a point. But in case of the UDL, means it will act throughout the length. So therefore we have to show with this symbol so that it will be distributed throughout the length. And here the magnitude will be given like this, some W newtons per meter length, because this is a length. So that means, so per meter length, so for example 10 Newton per meter, that means per meter, so the load acting is 10 newtons, and within that 1 meter the 10 Newton is distributed like this. So this is the uniformly distributed load. Now coming to the uniformly varying load, here what is happening is this load is here, if we take this is 0 point, and here we got some maximum value here. So here from one point of the length to the other point of the length, the magnitude of the load is gradually increasing from 0 to maximum value. And this kind of loading is called the uniformly varying load. And in this case, the shape of the load is like a triangle. That's why this is called the triangular load. And sometimes we may have the trapezoidal load also. So here, so this is load also one kind of distributed load, but here the load is varying from one end to the other end of the beam. So this is called the uniformly varying load, and here this is called the triangle load. Now we also discuss some of the terms related to the beams in the shear force and bending moment diagrams. So when you wanted to study about the shear force and bending moment, so first of all we should know the reactions. What is called reactions? So suppose a beam is loaded at 2 points, loaded at the midpoint and supported at the two ends. So here this beam is supported at the two ends and it is loaded at the midpoint with a point load. So here, due to this load, due to the action of this load on the beam, so here what is happening is the forces also developed, the forces also set up at the reactions, at the supports to withstand this externally applied load. So here what is happening is when the beam is loaded with some amount of load at the midpoint or at any point, to withstand this load, here what is happening is the forces are set up. Here the forces will be set up to withstand this load. So the forces set up at the supports are called as the support reactions, or simply reactions. Reaction means it is also kind of force which are set up at the supports to withstand the externally applied loads on the beam. So some kind of, so here also some, so to withstand this load, here some forces are set up. These forces are called as the support reactions or the reactions. The next one is the shear force. So shear force is nothing but the what? It is one kind of force. Shear force is nothing but the one kind of force. But to define the shear force, we have to select the what is called section. So we can take a section like this. Here what is happening is, so this is the, for example, this is the throughout the length of the, so this and this combined is the total beam. And here now we have taken the section at this point of the beam. So this is the XX section. Here what is happening is, we got, this is the, this side is called as the to the right of the section, and this side is called as the to the depth of the section. So here by definition the shear force, so the algebraic sum of the forces acting to the right of the section or to the left of the section is known as the shear force at the section. So generally, to find out the shear force exactly at the point, for example, I wanted to find out the shear force at this point, so then I should consider the section at this point. I have to draw a section line. Now this part is called as the to the right of the section, and this part is called as the to the left of the section. Now the shear force is nothing but the algebraic sum of the forces acting either to the right of the section or to the left of the section is called as the shear force. So here algebraic sum means some forces will be positive and some forces will be negative. So how, which force is positive, which force is negative, that we will discuss. How to select the sign convention, what are the positive forces, what are the negative forces, that we will discuss next. Now here what is happening is, but if you take this section, so it is very important to note that we have to consider only either to the right of the section or to the left. That means when you take a section at any point on the beam, then on the beam the algebraic sum of the forces acting to the right must be equal to the algebraic sum of the forces acting to the left of the section. That's why if you take either left of the section or to the right of the section, that will be same, but only we have to take only one side. That means, so the algebraic sum of the forces acting either right of the section or either to the left of the section is called as the shear force. And now coming to the bending moment. So bending moment also very simple, very same. What is the bending moment? The moment, we are saying that bending moment means the moment of a force. What is the moment of force? The force into the distance through which the moment is required. The distance of the magnitude of the force into the distance of the force from the point through which the moment is required is called as the moment of the force. So simply the moment of the force is equal to force into the distance. So here the bending moment is nothing but the moment of the force. That means, so here same thing, when there is a beam and loads are acting on the beam, then we should consider the section. We can consider the section at any point. at any point on the length of the beam. Here, suppose we have taken the section at this point, and here this is the to the right of the section, and this side is called the to the left of the section. Now here, due to the forces, some moments are acting, and here also some moments are positive and some moments are negative. Generally, the clockwise moments are taken to be positive here, and anti-clockwise is negative. So anyhow, that sign convention will be taken, and later on that we will discuss. And here what is happening is somehow the algebraic sum of the movements. So generally, so some are the positive movements, and some forces are creating the negative movements. So we will be getting the resultant movement, that is nothing but the algebraic sum of the movements. So that algebraic sum of the movements acting either to the right of the section or either to the left of the section is known as the bending moment acting at that point. So to define the shear force or the bending moment, so first of all we have to select a point. So at what point we require the shear force or bending moment, because the if we take the total length, so at every point throughout the length, the amount of the shear force and bending moment is varying. So therefore, we have to select a point at which the bending moment is required, or at which the shear force is required. And at that point, we got the two sides. So one is to the right of the section, and second is to the left of the section. So the bending moment is nothing but the algebraic sum of the moments of all the forces acting either to the right of the section or either to the left of the section is called as the bending moment acting at that point. Now we have defined the shear force and also the bending moment. Now the next important term is the point of contraflexure. So this is very important here. As I said that the some of the shear force are positive and some of the shear force are negative, and also the if you take the moments also, bending moment also sometimes it may be positive, the algebraic sum may be positive or negative at any point throughout the length of the beam. So therefore here what is happening is the a point of contraflexure means it is a point on the beam at which the bending moment is zero or changes sign, at which the shear force is zero, and or the changes sign from positive to negative or vice versa, that is or negative to positive, is called as the point of contraflexure. So point of contraflexure is nothing but the it is a point on the beam at which the shear force is zero or its changes sign from the positive to negative or negative to positive is called as the point of contraflexure. And one of the important thing is that whenever the shear force is zero, at that point the bending moment will be maximum. And so to locate the maximum bending moment, we should make use of the point of contraflexure, and generally so it will happen where the shear force is zero or it changes sign, that is the shear force changes sign from positive to negative or negative to positive, that point is called as the point of contraflexure. And one more important thing is that at the point of contraflexure the bending moment is maximum. Now the sign conventions. So as I told you that some of the forces will create positive shear force and also positive bending moment, and whereas the some of the loads acting on the beams are creates produces negative shear force and also negative bending moments. First of all, we should know which force creates which type of shear force or which type of bending moment. But we should not say that it is not true that a positive shear force will always produce a positive bending moment, and a negative shear force will also always produce a negative bending moment. It is not like that. The shear, whether the shear force may be positive or negative, it may also produce a positive or negative bending moment. And to decide the signs, that is positive or negative to the shear force and also bending moment, actually there is no universally accepted sign conventions. But however, we are following the procedure which is followed here. Generally, in some books they may follow the different books. They may follow the different conventions. So suppose some author if takes it is a positive, some other author it may take negative. But however, the amount of bending moment acting or amount of shear force acting will be same. But the sign may be different. But however, the following standard sign conventions are generally used, that we will discuss here. So first one is the all upward forces acting to the left of the section will cause the positive shear. So here what is happening is all upward forces acting to the left of the section. So upward, so here this is a section. So to the left upwards. So upward forces acting leftward will cause a positive shear. And the opposite to this one, what is the opposite to? If it acts upwards to the left, the downwards to the right is also positive. So this one. So upwards to the left also positive and downwards to the right also positive. So this is a, so here either this force or this force, both are positive. So this produces the positive shear, and this is the diagram for the positive shear. And next one is all downward forces acting to the left of the section cause negative shear. So all downward forces acting to the left. So this is the downward force acting to the left. So to the left of the section acting downward. So downward force acting to the left of the section will cause the negative shear. And similarly, the opposite to this one, what is that one? If we take the rightward and upward force, if we take the leftward, it is a downward force, and opposite to this one, if we take the rightward, it is a upward force. So an upward force acting to the right of the section is also negative. So here this is the sign convention for the shear force. So very simply you have to remember that. So you take the section. So the downward force acting to the right of the section is positive, whereas the upward force acting to the left of the section is negative. So this you must remember. The downward force acting to the right of the section will cause a positive shear force, whereas the upward force acting to the right of the section will cause a negative shear. And similarly, we can say if this is a positive, what happens to the right is positive, so to the right acting downward is positive, so to the left acting downward is negative. And similarly, when to the right acting downward is positive and to the left acting upward is positive, and this when to the right acting downward is positive, then to the right acting upward is negative. So this is negative. That in that way we can remember, and you remember that this is the first only thing is this you have to remember. When the downward force acting to the right of the section is positive, then we can decide the sign of any other force acting either to the left or to the right of the section. And the sign for the bending moment that we will discuss in the next class. And here coming to the summary. Now in this class we have discussed about the beams. We have defined the beams, loads, and we discussed about the types of beams, as they are the cantilever beam, simple sorted beam, continuous beam, overhanging beam, fixed beam. And coming to the types of loads, we got the point loads and the distributed loads. In the distributed load also we got the UDL, that is the uniformly distributed load, and also UVL, uniformly varying load, triangular load, and trapezoidal load are the example for the UVL. Next, we have defined the shear force and also the bending moment. Shear force is nothing but the algebraic sum of the forces acting to the right of the section or to the left of the section is called as the shear force. And coming to the bending moment, the algebraic sum of the moments of all the forces acting either to the right of the section or to the left of the section is called as the bending moment. And just now also we have studied about the sign conventions. So if a downward force acting rightward, it is taken to be the positive for the shear force. So this is about the topics that we have covered in today's class. Now the remaining things we'll discuss in the next class. So thank you all of you.